Hey all, today we're going to explore the concept of density. Density is actually a combination of physical properties of an object. Density is known as the ratio of the mass of the object to the volume of the object. We can write that kind of as an algebra equation where D, density, equals M, mass, over V, volume. Some books don't use a D for density. Some books use a crazy little Greek letter. It's called a rho. But we're going to use a capital D. Now, because density is a combination or comparison of two physical properties, mass and volume, well, we need to discuss mass and volume. So volume is how much space does an object take up? And if you were in math class, volume would be length times width times height. And that's true. If you have a little box and you wanted to know how much space the box took up, you could measure it on each side, length times width times height. In this particular box, it happens to be 10 centimeters on each side. And so 10 centimeters times 10 centimeters times 10 centimeters will be 10 times 10 times 10. That's 1,000. That will be 1,000 cubic centimeters. Unit of volume. And so, speaking of another example of volume, I have this little cube, this little orange cube. And this little orange cube happens to be, if I can get my fingers out of the way, 1 centimeter, just about, on each side. So this is just 1 centimeter cubed, because 1 times 1 times 1 is 1. And we have to cube the units. So we have 1 centimeter cubed. This box, 10 by 10 by 10 centimeters, which is 1,000 centimeters cubed, which means that this box can hold 1,000 of these, which is absolutely true. And what I can do is take 10 times 10. This is 100 of those little cubes all locked together. It's 10 times 10. Plus another 100. Plus a lot more hundreds. Get them in here. Plus some more. Plus some more. Plus, these are strips of 10. Dropping them, hold on. Okay. And then I do have a few individuals. And I put them all in this box. And if I put them all in this box, all of them, I end up having 1,000 cubic centimeters in this box. What's important here is that 1,000 cubic centimeters is equal to, and was defined as many moons ago, a liter. So, now you might be familiar with a liter, because I have this bottle of seltzer. It is a 1 liter bottle. 1 liter. So we have two kinds of units of measurement going on, but they have equivalency. We know that 1 liter equals 1,000 centimeters cubed. So we have liters and we have centimeters cubed, but they have a relationship there. Not only that, but it was defined a long time ago that 1 little cubic centimeter, 1 cubic centimeter, will be 1,000th of a liter. So if we kind of write this in a different way, 1 cubic centimeter, well, if I divided this side by 1,000, I'd have to divide this side by 1,000. And that would be 1 over 1,000 liters. And we called this 1 over 1,000 liters, we call this a milliliter. Milli being the prefix, the metric prefix for 1,000, a thousandths, a division of 1,000. Which is wild to understand. But this, in this little tube, I have a little bit of liquid, I have it slightly colored. This little bit of liquid is a milliliter in this little tube. That volume and this volume are the same. See if I get it to stay. Okay? So if I were able to take this little box and I were able to empty it or make it all just sides and not fill the middle, I'd be able to pour this liquid into this little box. So 1 milliliter is equal to exactly 1 centimeter cubed. So we're going to interchange these. And by the way, not only do we have to worry about that, but sometimes, not so much in our class, but if you ever watch those medical shows where the doctors are like, give me 50 cc's of something, something stat to, you know, help the person who's injured. Well, cc is a non-standard way of saying cubic centimeter, cc. In science class, we generally don't use cc, we use centimeters cubed. So this very strict length, width, height scenario gave us the ability to measure volume in not so nice rigid shapes. Matter of fact, if I take my box, well, first, before I take the box, I told you this was a liter. This is a liter. They're about the same. They have slightly different shapes, but trust me, 1 liter, 1 liter. Now what I'm going to do to prove that to you is I'm going to take my 1 liter, which is just a slightly colored water. I'm going to pour it into my box. Fill to the rim. Okay, that's 1 liter. Now what I'm going to do, without spilling this hopefully, hold on, it's going to be a minute. Give me a second. Without spilling it, I'm going to try to pour it into this vessel. Now it's going to spill probably, but we'll try. Did it. A little splash. A liter. And then I'm going to take this and pour it into this vessel. It didn't fill it all the way to the top because the top isn't all the way marked for the 1,000 milliliters. So there's a marking there. I don't know if we can see it in the camera, but let's see if I can get it to shine there. It's kind of there, 1,000 milliliters. Trust me, it's there. So a liter, which is 1,000 units of water that are milliliters. So those are the two basic volume measurements that we're going to be using. So I wanted to give you a sense of liters and milliliters. A milliliter is 1/1000th of a meter, of a liter, I'm sorry. Now, mass, well, this gets a little wild. mass we generally use in this class grams. Now there's all different kinds of versions of mass, but we generally use grams or kilograms. Well, back in the day, this amount of water, a milliliter or a cubic centimeter of water, specifically water, a milliliter of water, if we were to put that in a little box and put it on a scale, that is 1 gram of water. That's the mass of water. The gram is based off of, that mass measurement is based off of water in its particular volume. A liter of water defined a kilogram of mass. So water was the standard for mass in the beginning. And things have changed since then, but for now, or in history, that's what happened. Now, we typically find mass in grams on a scale, right? If you're in science class, you'd come into science class and you would find your mass on a scale. You just put the object there, would read it in grams or ounces, and we don't use ounces in this class. Now, that's an English measurement, or British measurement. We're not using that. We use grams or kilograms. But again, kilograms and grams are related because this little itty bitty thing, that's not even a gram, that's 10 grams. That little mass, it's got a little mass with a little hook. So 1 gram is really small, so that's 10 grams. This big piece of metal compared to this is 1 kilogram. This will be 1,000 grams. This is 10 grams. So basically, 100 of these makes this up. So we, in this class, use kilograms, and that would be equal to 1,000 grams. So when we read problems and compare objects, we're going to think scientifically, we're going to think metric, we're going to think in terms of liters or centimeters cubed, and again, they have a relationship. We're going to think of things in terms of grams, or a bigger version of that, which is kilograms. Coming up next, we're going to actually talk about this ratio combined and look at the comparison of objects and their densities.